Products we use every day have the potential to be improved. Sometimes the products we use less often have even more room for improvement. Take, for instance, this simple shopping basket. So what we propose is Shopping Basket 2.0.
In the past 40 years, there haven't been many improvements made to how we shop. Shopping baskets and carts have been around for almost 100 years and are still very similar to the original design. We think that there needs to be new innovations in the shopping experience.
So why does the shopping basket truly need to change? Despite the inception of the shopping cart in the early 1900s, it took until 1946 for engineers to change the design to one which could successfully nest inside other carts, thus reducing space the carts occupied inside of the stores. Aside from that change, the only new innovations to shopping have been the advent of different ways to carry items, such as rolling suitcase-style baskets and motorized carts.
Typical problems that arise when using the shopping basket include arm fatigue, causing shoppers to buy vice items like candy bars and soda impulsively. Carrying a basket around the store for too long causes shoppers discomfort, so they tend to shorten their shopping trip, which is not ideal for stores. Shopping baskets lack an ergonomic design made for their current user population. When I was actually on a shopping trip to Giant Eagle, I used a basket since I was only picking up a few things. After walking around the store for only a few minutes, my hand was already starting to hurt, and I kept having to readjust the basket. To begin our redesign, we first looked towards NIOSH to find the suggested metrics for a tool such as a basket. Since a basket is a single-handed tool, the grip diameter should be about 2 inches. Making each handle half 1 inch across, we fit this recommendation. We also decided to align the handles lengthwise across the basket so that the arm can hang naturally and the basket can be comfortably kept close to the body as per NIOSH recommendations.
Now that we had considered the reasoning behind taking steps to improve the shopping experience, we had to consider what the market was like for such a product.
Studies show that shopping in traditional brick-and-mortar stores has become increasingly less popular, while online sales are still on the rise.
Last year alone, through 3.8 million establishments, the retail industry raked in $2.6 trillion in sales. Brick-and-mortar stores are slowly disappearing, but supermarkets will always be needed. For the last 10 years, the number of grocery stores has risen to over 38,000 nationwide.
Almost every store uses shopping baskets in some form. They are especially useful in smaller stores and markets where full-size carts may not be feasible.
A lot of this is due to the impingement of how shoppers use baskets inside the store. Using a cart provides traffic that most smaller establishments cannot handle, especially when trying to have omnidirectional flow of shoppers in cramped aisles.
Our main goals for this product are to reduce arm fatigue, maintain the weight distribution in the basket, remain as cost-effective as current solutions, and design our product with the shoppers in mind.
Now that we had established how we wanted to improve the shopping experience, we had a clear vision of how to implement changes to the current design in order to meet our objectives. By redesigning the handle and reorienting the handle direction, we could meet all of our objectives. We just had to be careful to not stray too far from the standard basket design.
There are certain requirements for a user to be able to use our product. The user must be able to lift 3 pounds with one hand. The user must be able to sustain the 3-pound grip on a basket for 41 minutes. The user must be able to fit 80% of the desired items in the basket. The user also must be able to lift a fully loaded basket to a checkout line height of about 38 inches. The user must have a range of motion to reach 16 inches from the ground level to pick up the handles. And finally, users must be able to properly identify where to stack the baskets with less than 5% chance of error.
Our very first design incorporated the essential components from our objectives, but it did not have a defined solution for the handles quite yet.
With this iteration of the design, we primarily wanted to focus on the ergonomics of the handle. The handle will be made of 2 identical, rotated injection molded pieces that fit to the NIOSH standards for grip size and interlock magnetically to prevent the handles from falling when the basket is placed on the ground.
Our final design took all of the elements from our previous design and added a more ergonomically designed basket. This curved shape will allow the basket to sit closer to the body when it is carried. There is an overall depth increase of the basket to retain the same volume as the previous design despite the profile shape change. The height increase, along with the handle design, allows for easier pickup and set down of the basket with minimal bending of the trunk and strain on the lower back.
To manufacture the basket, we will use the process of injection molding. The manufacturing of the handles will also be done by injection molding, and will create two identical molds rotated to fit on either side of the basket. The handles will then require some minor assembly to be attached to the basket. By injection molding all of the components, we will be able to produce large quantities quickly and cheaply following the upfront cost of creating the molds. The process won't be fully automated though, since human assembly will still be required to attach the handles. Following the completion of our design and production process, we analyzed our final solution.
Circled in red, you can see the weight and total cost per unit of each the basket and the handle assembly. At 2.92 pounds and $4.24 for each unit, we came in only 3/4 of a pound overweight and $1 increased in costs over the standard shopping basket. Both of these met our original design objectives. The users of our product are still your average grocery shoppers, needing a small amount of groceries. However, the ergonomic design should expand the user group to include older users that had issues gripping the basket or bending over too far previously. Our design also doesn't alienate those who are left-handed or right-handed from the shopping experience. Changing the basket orientation doesn't influence how the basket is to be carried by either type of user. Some drawbacks to our design are an increase in production costs, which we noted earlier. We tried to offset this cost by making all parts for one half of the handle assembly identical to the other half. This cuts our number of molds in half and our number of distinct parts, thus lowering our overall production cost. We are also restricted by confounding design objectives in our original goals, such as the length of the handle versus the stackability and capacity of the basket. If we were to increase the length or size of the handle too much, we would lower the overall capacity and thus have to change our design.
The benefits of our design far outweigh the drawbacks. More basket usage encourages less traffic in aisles. More comfort can result in longer than average shopping trips. Less arm strain reduces the adrenaline release and decreases tendency to purchase unnecessarily. Using a basket instead of a cart reduces excessive purchases, which is great for the customer.